Lesson 7-4, Sound Intensity and Sound Level. Sound waves carry energy that can do work. The amount of energy transported per second is the power. So sound waves, you can feel them push. They push on your eardrums, push force and a distance, so it does work on you. The amount of energy per second is power, and so the units of the power would be joules per second, or a watt. As sound moves away from a source, it spreads out over a larger and larger area, as you can kind of see in the picture. As the area gets bigger, the intensity at any one point gets less. So we're going to define intensity as the power per area. Intensity is the power per area. So as the area gets bigger, the intensity gets less. It's an inverse relationship. The power is going to be constant in the wave. So it's the intensity and the area that are related to each other inversely. So as one gets bigger, the other gets smaller. The unit for intensity is a watt, that's our power, per meter squared. The area, it's a watt per meter squared. So you can see here it's a much smaller area, will be higher intensity. Over here on area 2, it's that same power spread out over a larger area. So the power in each individual bit of the area is going to be less. If the sound is transmitted uniformly in all directions, then the areas are surfaces of spheres. It's here, it's going same distance, same amount in all direction, and makes spheres. Area of a sphere is 4 pi r squared. So the intensity that's transmitted uniformly is the power over 4 pi r squared. Notice the intensity is proportional to 1 over r squared. So as the distance doubles, the intensity is divided by 4. So whatever happens with the distance, the intensity is the reciprocal of that squared. Double the distance, 1/4 the intensity. 3 times the distance, 1/9 the intensity. So it spreads out and dies away pretty quickly. The intensity is proportional to the amplitude squared. So our intensity equals delta P, which is our pressure amplitude squared, and over 2 times the density over the speed of the wave. Right? The density is the density of the mediums. Like if it's going through air, it'd be the density of air. If it's going through water, it'd be the density of water. And this is the intensity of sound. You and a friend are watching fireworks that are launching from the observatory. You're standing right in front of university towers, about 150 meters away. And your friend is across campus at AA, about 700 meters away. The sound intensity at AA is 0.2 watts per meter squared. What is the sound intensity at your location? And how much power is the firework emitting? Well, let's assume the firework goes up and it looks spherical, so let's assume that it is uniformly in all directions. So our intensity is our power over our area. All right, we know at AA the intensity is 0.2. And we could find our power. The radius would be 700 meters. You solve for P, and you get 1.23 times 10 to the 6th watts. Okay, so that's our first answer. How much power is emitting? That's the power. So 1.2 megawatts. quite a bit of power. That's why you don't want to be right next to the firework. It'll blow you up. Now, so that was at AA. Now let's go to the towers and do the same thing. We're looking for the I. The power is constant, but our distance is now 150 meters. So that gives you 4.36 watts per meter squared. Well, how loud sound is related to the intensity. So we talk about sound level in decibels, and that decibels is the unit of measure to compare two sound intensities, and it's based on how the human ear perceives loudness. Because it turns out if you double the intensity of the sound doesn't sound twice as loud. In fact, it uses a logarithmic scale. So intensity level, this is different than just intensity. This is intensity level, or we're going to use it for determining loudness. Beta equals 10 decibels times log of I over I0. The beta is the intensity level. I and I0 are the intensities of our two sounds that we're comparing. I0 is often 1 times 10 to the negative 12 watts per meter squared, which is called the threshold of hearing. Because that is the softest sound the average person can hear. The unit, dB, is a decibel, 10 bells. And note the intensity level of 0 means simply that your two intensities are exactly the same, has the same loudness. This is comparing two loudnesses. It's just we often compare to the threshold of hearing. So intensity can be measured. So in physics, science, we like to be able to measure things. Intensity is measured. Loudness, though, isn't measurable. It's simply how your ear perceives. And different people think things are different loudnesses based on how their ears hear. We do know, though, that doubling the intensity does not double the loudness. Let's say you double the intensity of the sound coming from a stereo. What is the change in loudness? Well, we can use the decibel formula. All right, now remember, the I and the I0 are simply two intensities we're comparing. So the simplest way is if we double our intensity, we can say our I is the same as 2I0. So our I is twice as much as I0. So it's doubled. The I0s cancel, and you end up with 10 decibels times the log of 2, which is about 3 decibels. So when you double the intensity, it only goes up by 3 decibels. So that means a 200-watt stereo will only sound twice as loud as a 20-watt stereo. Experiments have shown that if the intensity level increases by 10 decibels, it will seem about twice as loud. So you have a table in the book and the notes, and it lists different intensity levels, decibels, of different sounds. Just remember, every time you go up 10 decibels, it sounds about twice as loud. So what is the intensity of a 20 decibel sound? So I'm looking for the I. Now we don't have any to compare this to, so we're going to compare it to the I0, which was 10 to the negative 12, the threshold of hearing. So use the intensity level formula. We know we're at 20 decibels. And we're looking for I. I0 will let be 10 to the negative 12. So divide by 10 decibels. And then we have to remember, how do we get rid of a logarithm? Well, this is a common log, so the base is 10. So if you remember from algebra, we'll make 10 the base of both sides. So we have 10 squared, and 10 raised to the log base 10 cancels out. And then I can just multiply both sides by the 10 to the negative 12, which gets me 10 to the negative 10 watts per meter squared.